Ladies and gentlemen, this is your captain speaking. We would like to welcome you aboard our Smart House project presentation. Estimated flight time is around 10 minutes. We hope you enjoy your trip. And this is our house. Wait. This is our house. What you see in this video? You see a moving roof, ambient light control, some party lights, an opening window, an alarm in the wall, and a unique fire alarm. And the best thing is that everything in the house is controlled by this Android application we created. The application communicates with the C# server we also wrote, which we run on the computer the Arduino is connected to. You know how it's always just too bright or just too dark in the room? Imagine you're enjoying a good book in the late afternoon while the sun is setting. You eventually have to get up from the chair and turn on the lights. In our house though, this is not the case. In the first days of our project leader told us of a friend of his who used to suffer from severe muscle atrophy, and this gave us the idea of making an application that can open a window. Later on, we expanded this idea and created the application to control the whole house. Okay, the opening roof. This feature can be used for opening up new space for parties, or maybe reading a book while enjoying the ocean breeze. And honestly, most of all, we just thought it would be very cool to have a roof that opens and becomes a huge terrace. In order to open the roof, we fixated the metal rod to the servo, and to close it, we used a bracket which pulls the roof up again. After consulting some construction engineers that we know, we were assured this project was accomplishable in full scale. Have you ever sat at home thinking, man, how cool would it be if I had some party lights that blinked faster the closer I got to them?
No, dude, never.
Well, we have. We've created 3 different circuits with a common ground. One circuit with red LEDs, one circuit with green and white LEDs, and one with blue LEDs. The interesting part here is the infrared distance sensor. We have fitted this into the wall, and the closer you get to it, the faster the lights blink. Representing any modern TV, our LCD has a constant connection to the internet. We decided to show the temperature and the weather which we receive from an online weather service. Setting up the screen was quite simple. We just connected it to the right pins and built it into the wall. Everyone has trouble getting up early in the morning, but this is especially true for the members of our team. There are many people who just hit the snooze button over and over again until they're late for work or school. With that in mind, we created a smart alarm clock, sure to make you get out of bed in the morning. We built the infrared motion sensor into the wall in just the right place so that you'd have to stand up in order to trip it. Here is our Arduino code. In the beginning, we include 2 of the libraries we're going to be using, the servo and the liquid crystal library. Then we declare the pins that we're going to be using. Here are the pins that we're going to write on, and here are the pins that we receive data from. We declare our 2 servos and our LCD. These are 2 strings and 2 chars. You'll see later on what we are using them for. Here are some variables that will represent the data we receive from the sensors. And here are 5 Boolean variables. You'll also see later on what we use those for. Here is the setup function. First we begin the serial communication. Then we initialize the liquid crystal display. We pin mode the sound and some of the light pins. We attach the roof servo and set it to the initial position. Then we detach it in order not to meddle with the voltage from the board. We do the same with our window servo. Here is our get serial string function. This is the function we use to receive information from the server. Here we save every line we receive from the server. We know a single line is a single command. We save this line into the incoming string variable. Here is the set light function. This is the function we use for ambient light control. In the first part of the code, we read the slider value we receive from the server. Then we read the light that enters the room. And if this light is greater than a set threshold, or is greater than the light we would like to have in a room, we turn off our lights. Otherwise, we unlock right on the LED pin the difference between the desired light and the light that enters the room. This is the function for opening our window. It's kind of similar to the function for our lights. Again, we read the slider value, then we just attach the servo, write the value on the servo, and detach it. This is the function we use to open and close our roof. We named it change roof. First, we attach the servo. Remember, we detached it in the setup function. Then, in the isDown boolean variable, we save the information we read from the server for the roof being down or not. Then we emit sound 3 times from the piezo to warn people that the roof is closing or opening. And if the roof is down, we bring it up, and if it's up, then we set it down, then we retard the servo in order not to meddle with the voltage. This is the function for alarm clock. Here, if our boolean variable alarm on is true, so if the alarm is on, we make the gotup variable false, and while it's still false, we emit sound from the piezo. If the infrared sensor is tripped, we have a delay of 200 milliseconds, and we do another read of the sensor. So if that read is also 0, we make the gotup variable true, thus stopping the alarm. This way, if you throw an object in front of the sensor, it won't stop the alarm, and you have to get up from the bed. This is the function for the fire alarm. Here we read the value of the temperature sensor above the stove, and if the reading is over a set threshold and the fire alarm is not already on, then we make the fire alarm go off. We send the string to the server, and when the temperature gets below the threshold, then there is no real danger of fire, and we turn the alarm off. This is a function we call update LCD. Here we just write the temperature and weather that we receive from the online weather service. Here are our two functions to get the information from the weather service. We get the outside temperature and outside weather that will later on print out the LCD. This is the party lights function. If our party button is on, we do a reading of the higher distance sensor, and we turn the reading into centimeters. Then we declare a variable called frequency. This is the frequency at which our lights will blink. Then we turn the lights on and off in sequence. That way, when you get closer to the sensor, the lights begin to blink faster. And our loop here is pretty simple. We just call different functions depending on what string we receive from the server. And now for the ambient light control. Here you can see, as we change the value of the slider, the brightness of the LEDs changes too. This way we can set the desired level of brightness. Once we have done this, you can see, as the outside light changes, the light inside reacts to it and keeps the same level of brightness in the room. As we shall now demonstrate, the window is incredibly easy to control. You just use the slider to set the angle at which you want it to be opened. And as you can see, it works flawlessly. As I click the roof open button, the house warned us that its roof is going to open, and it was supported on the columns. And as I click the roof close button, it gives another warning and closed its roof. Now as you can see, it's 1:49, and I'll just set the alarm for 1:50. Okay, and I click done. I exit the application. I'll just leave the phone here, and we wait for a minute to see, hear how the alarm goes off. As you can hear, the alarm goes off, and now I'll bring my hand in front of the sensor, and the alarm should stop. There we go. When I hit the party lights button, the party lights turn on, and when I change the distance between my hand and the sensor, the lights change the frequency at which they blink, meaning the code we have written works. Okay, here I minimize the application. We've got our stove turned on and left it unattended. Any minute now, the hot plate should get hot enough for the sensor to detect it and send a message to our phone. Also, the power to the stove should be cut off. That will happen any minute now. We just sit and wait. Oh, there you go. I now just take the phone. And click dismiss alarm. And my house is not set on fire.